This is problem number 3 from section number 1. In question A, they ask us to determine the change in the range, and by this we know that we have to find the increment. The formula to find an increment is delta y equals f of x2 minus f of x1. In this case, they gave us x as data, so we know that x1 is 10 and x2 is 11. We also know that velocity equals to 2,500. So then we substitute this information they gave us into the increment formula, which in this case it will be 2,500 squared over 32 times sine 2 times 11 minus 2,500 squared over 32 times sine 2 times 10. Then you plug that in the calculator and you should get the answer with the proper notation, that is delta y equals 6,364.5410. For question B, they ask us to use differentials to approximate the change in the range, so we know that we have to find the differential. The formula to find the differential is dy equals f prime of x times dx. To find the differential, first we need to derivate the equation, which in this case is 2,500 squared over 32 times 2 cosine of 2 theta. And we substitute the information we already have into the equation, that is 10 in theta and 1 in dx, because 11 minus 10 equals 1, so that is our dx. So the final equation is 2,500 squared over 32 times 2 cosine of 20 times 1. You plug that in the calculator and you write the answer with its proper notation, that is dy equals 367,067.43. For question C, they ask us to interpret our results within the context of the situation. The situation of this problem is a range of a projectile where the velocity and the angle of elevation is measured. Our answers were different, but we consider that the increment answer is the most accurate one. For question D, they ask us under which circumstances is it better to calculate the actual change and when the approximate change. Because this is a projection of something, of an object, it will be more accurate to use the increment formula for a more exact position of where the object is going to land. But for an estimation of where the object is going to land, you can use the differential formula. This is problem number 30 from section number 2. For this problem, they were asking us to integrate this equation. Because this equation is divided by only one term, we arranged it. So the first step in this problem is to rewrite every numerator divided by the denominator in separate ways. Then the next step is to pass the variables in the denominator into the numerator as a negative exponent. Then we simplify the exponents of the variables, in this case, the exponent of the x's. After we simplified, now we have to integrate with the formula, that is the exponent of x plus 1 over the exponent plus 1. After integrating, we have the final answer. But first, we have to put the proper notation. That is, the integration of f of x dx equals to the answer, which in this case is x plus 2x cubed plus 6 over the cubic root of x to the fourth power plus e.